Hey there, everybody. Welcome back. We were looking at line integrals and only integrating with respect to one variable. And we wanted to see if orientation matters along the curve. So let's use the function. Our function is going to be sine of pi y in the y direction and yx squared in the dx direction. We're going to go along the curve. It'll go from 0,2 to 1,4. We're just going to use a straight line. And then going the other direction, we'll go 1,4 to 0,2. So I mentioned that we would show you how to do this in a later video when we had 0,1 and 1,0 earlier. Remember that RT, R as a function of t, is the same thing as 1 minus t times R naught plus t times R1. So R naught will be the first vector that we're started going with, and R1 will be our second vector. And when we go the other direction, R0 is the 1,4 and R1 is the 0,2. So let's take a look at what happens. If I calculate R of t, I've got 1 minus 2 times 0 to 2 plus t times 1 to 4. You can see we've got 0 times 1 minus t plus 1 times t. We get 0 plus t for the first component. And then I've got 2 times 1 minus t plus 4t. So 2 times 1 minus t plus 4t. R of t ends up being t plus 2t. And we're going from t equals 0 to t equals 1 when we do this. And you can check it, plug in 0 and 1 and make sure you get your vectors the same. And so when we're doing this, we got to replace in our function pi y gets replaced with 2 plus 2t, and x over here and x gets replaced with, t, and y is still 2 plus 2t. So we've got this, we're going from 0 to 1. Those are dy dx though, we need them in dt. So just take the derivatives with respect to each. Dx will be 1, dy will be 2. So we plug those in, and I separate them into two different intervals, just to make it a little bit easier. And I could use the fact that 2 pi plus 2 pi t, that's a cyclical thing, so we don't really need the 2 pi, but I went with the whole thing. You can work it out. You're going to see you get 7/6. Pause the video if you need to check that out. Let's do B, where we're going in the same path but the opposite direction. So we're starting at 1,4 and we're going to 0,2. So remember, we're doing 1 minus t times R0 plus t times R1. That's our R of t. And I end up getting 1 minus t and 4 minus 2t. Make sure you get the same. And we needed dx dt and dy dt. In this case, it's -1 and -2. So I'll plug that all into our functions with our new x's and our new y's and our new dx dt's and our new dy dt's. And there's a lot of integration here. I suggest you pause it and go over it. I don't want to explain it to you. You know how to integrate sine and polynomials. I end up getting -7/6. If you recall, we got 7/6 last time. So orientation matters. Going one direction had a positive value and going the other direction had a negative value. So reversing orientation along the path changes sign. That's effectively what it does. And we denote that by C is a directional thing. We're going in one direction. If we want to go in the other direction along the curve, we denote it as -C. So that's the opposite direction. So if we go the opposite direction along the curve, is the same thing as doing the negative version of the forward direction along the curve. Same thing goes with dx. It's dx dx, and same with dy's. But remember, ds orientation didn't matter, so -C or C didn't change the outcome. So that's the one big difference between doing the line integral along the whole thing and then doing it piecewise by variable. Why do we care about that? You're going to see shortly. Peace.